It's important, mark it important. Take your book, man. Okay. Tulsi will boy. They have an impression about you. They lost completely all this thing. They thought you were a good boy. Did you write Gauss's law? Very good. Siddharth Babani is here. Siddharth.
Yes, sir.
Do you have any idea about Gauss's law or something? No idea?
No idea.
No idea. It gives the electric flux. Can you write down? I will give the statement first, okay? Please write the statement of Gauss's law. Can you write the statement? The flux of electric field. The flux of electric field. Can you see the screen? This is the statement. The flux of electric field through any closed surfaces is 1 by epsilon naught times the total charge enclosed by S. One by epsilon 0 times the total. If they are asking the statement, you have to write like that. Understood? Flux. The flux of electric field through any closed surface the flux of electric field through any closed surfaces is 1 by epsilon 0 times the total charge enclosed by S.
So can you record the class?
What is a good name?
So Abhishek.
Why you want to sleep now?
Sorry, sir. Can you repeat that?
Do you want to sleep now or not?
No, sir.
And why can't you listen to my class? You are in which class?
Yes.
11?
I'll see.
Sorry, 12? 12C. 12C boys are very smart here. They are writing the notes. The flux of electric field through any closed surfaces is 1 by epsilon 0 times the total charge enclosed by S. Finish? Okay. Then we come back to the textbook now.
Sir, could you show that again, please? Just 2
The
minutes.
flux of electric field through any closed surface is 1 by epsilon 0 times
The total charges.
enclosed. Total charge enclosed, please. What's a good name? What's your name?
Muzammil, sir.
Please write first. Finish now?
Yes, sir.
This is the mathematical part. Can you write down this also, please? Electric flux, this is the statement. Muzammil, this is also okay. Muzammil, can you hear? Hello.
Yes, sir.
Even if you write this, you will get the mark, full mark. But I give the statement, make it clear.
So, sir, do we note this down also?
Yeah, it's also okay. Can you write down this also? Electric flux through a closed surface S equals Q by epsilon 0, where Q is the total charge enclosed by S. Fancy finish? Goodbye. Can I write this also? Phi equals Q by epsilon naught. Put it in a box. This is known as Gauss's law. Phi is equal. Somebody is asking what is Gauss's law. Straight away you can write that. Phi is equal to what? Q by epsilon 0. Okay? Can you write this also, all of you? Or phi is equal to, put it in a box, this one. This, don't forget this. Phi is equal to Q by epsilon naught.
So in exam we can't use this part.
You can use it, no problem. But you have to mention that phi is the flux, Q is the total charge, epsilon 0 is permittivity of free space, etc. Are you okay, Tansim? Mohammed Mohammed? Sure. Proof is not in the syllabus, okay? I'm leaving it. Only the applications are there. Proof is not in the syllabus. Can you write the heading? Applications of Gauss's law. That is important, please. Applications of Gauss's law. Applications of Gauss's law. Applications of Gauss's law. Mark it important. There are 3 applications. Hopefully, first time they will ask one application, sure, 100%. And the final exam also, they are asking the applications. Mainly 3 applications are there. Number 1, you write. Number 1, this is the application. Field due to an infinitely long, straight, uniformly charged wire. Field due to an infinitely long, uniformly charged wire.
So this is the application of Gauss
Yeah,
law.
first, there are 3 applications. This is application number, first application, okay? Number 1 application, okay? Can you hear me? My sound is clear?
Yes, sir.
Heading over, all of you? Mansur over? Next, this top diagram, no need of drawing. You have to draw this one, a cylinder and all. Can you see that figure B? This diagram is compulsory to draw it. Can you draw the diagram, please? Center, there is a charged wire. Then they are creating a cylinder around it. L is the length of the cylinder, R is the radius of the cylinder, please. Writing. Small l is the length of the cylinder, small letter L, okay? R is the radius, and P is a point. I think mom told you what is the formula for flux? Phi is equal to what? E into delta S. You know that? Flux phi E into area. That is known as the flux.
So can you repeat that again?
You know the meaning of flux only asked. Flux is what? Anybody knows? Electric flux is? Phi is what?
So Q by epsilon 0.
No, that is Gauss's law. Really, flux is electric field into area, you know. E dot delta S, okay?
Oh, okay, sir. All right.
That's the meaning of it. Okay, can I start? Almost finished, Mr. I need the first, some introduction I need it. First sentence, can I write down? Consider an infinitely long, thin, straight wire with uniform linear charge density lambda. Please, first sentence, all of you copy that one. Consider an infinitely long, thin, straight wire with the uniform linear charge density lambda. Om is here, Om Rajesh is here. Oh, you are Om Rajesh. Okay, why the other voice that you are a gangster and not you're a good boy? Om Rajesh. Okay. No, he looks very decent guy. Okay, Om. Thank you. Okay, first sentence over, Om. Let me cut short the other thing. I mean, the paragraph is so lengthy, I will cut short it, okay? Can I write next sentence, all of you? P is a point. I don't, P is a point. Can I hear, understand, or can I listen? P is a point at a distance. P is ohm. P is a point at a distance r, small r, at a distance small r from the wire. P is a point at a distance smaller from the wire. If you want to apply Gauss's law, we have to create a surface, you know. That surface, we call it as Gaussian surface. It is a colloquial word. We create a surface, so that is known as Gaussian surface. For example, this is my charged wire, and you want to find the field at a point. You make a cylinder like this. Wire is inside. Point will be on the surface, curved surface. If the point is too far, the radius of the cylinder will be large. So this kind of cylindrical surface created by you in order to apply Gauss's law is known as a special name known as Gaussian surface. Okay, continue next sentence, please. Did you write P is a point at a distance r from the wire? Clear? Next sentence. To find the electric field at P, to find the electric field at P, Gauss's law can be applied. To find the electric field at P, Gauss's law can be applied. Finish. Next sentence. Choose a Gaussian surface. Spelling is here. Can you see the spelling here? Gaussian surface. This is the spelling. Choose a Gaussian surface to be a cylinder of, choose a Gaussian surface to be a cylinder of radius r, to be a cylinder of radius r, small r, and length L, small l, so that the point P lies on its curved surface. So that the point P lies on its curved surface.
So can you repeat?
Sure. What is the first sentence? Oh, what did I say? Choose a Gaussian surface, huh? Yeah, write down. Choose a Gaussian surface to be a cylinder of radius r and length L. Finish. So that the point P lies on its, curved surface. So that the point P lies on its curved surface. All of you understood up here? Consider a long wire. Find the electric field at P. Choose a Gaussian surface. Be a cylinder of length L. Did I mention L or something? Okay. And radius R. You know that electric flux through the top and bottom is zero because electric flux is going E dot E ds cos theta. Really is E ds cos theta. Top and bottom is cos 90. It will become zero. Otherwise, imagine that radial field. Field goes like this only. I'm ignoring the top and bottom surfaces now. Okay. Sentence right. The flux through the flux through the curved cylindrical part of the surface. Let's see that I will underline, I will highlight it. Flux through the curved cylindrical part of the surface is finish. Flux through the curved cylindrical part of the surface is finish, all of you. I'm cut shorting it. Slight modification. I am changing the derivation slightly so that it is easy for you. Phi is equal to, the formula E dot delta S, you know that? E dot what? Delta E dot ds, okay? E dot S. What is the curved surface area of a cylinder? You know it. What is the curved surface area of a cylinder? 2 pi r. So it will be E into 2 pi RL. Equation number 1. Please, all of you write. Flux through the curved surface is phi is equal to E into 2 pi RL, equation number 1. Finish. First sentence, first step is okay? Very good. Aaron Almeida is here? No. What's your name, Mr. Huh? Can you hear me? Net is working?
Yes.
Can you hear me now? Okay, can
Yes,
you
sir.
hear? The net got disconnected. I'm sorry. Okay, please. Okay.
No problem,
What
sir.
is the? Yeah. You wrote according to Gauss's law, isn't it? First one is, I think.
Because tomorrow they'll be going.
Yeah. Okay. Thank you. Flux, first I wrote phi is equal to 2 pi, what is that? E into 2 pi RL, isn't it? Okay. Next, according to Gauss's law, write down, according to Gauss's law, please write down, according to Gauss's law, you know the formula phi is equal to what? Q by, you know it, phi is equal to what? Q by epsilon naught, please. Equation number 2, according to Gauss's law, phi is equal to Q by what? Epsilon. Very simple derivation. Okay, first you write phi is equal to E into 2 pi RL, then call Gauss's law, phi is equal to Q by epsilon 0, equation 1 and 2. All of you know that left side is the same, then naturally what happened? Right side will be same, you know. Okay, clear? Did you finish, all of you? Hello, gentlemen. Online boys, did you
Yes, sir.
finish?
Yes, sir.
Write down from equations 1 and 2. From equations 1 and 2. From equations 1 and 2, E into 2 pi r L equals Q by epsilon naught. Make E subject of the formula, that is all. E is equal to Q by 2 pi epsilon 0 RL. I told you lambda is the charge per unit length. Your L is the length of the conductor, so total charge will be L, lambda L. Did you finish up here, all of you? But Q is equal to, write down, but Q is equal to lambda L, total charge, bracket you right, okay, lambda L is okay. Q is equal to lambda L, then Q is equal to lambda L, okay? Q is equal to lambda L. In that, E is equal to lambda L divided by 2 pi epsilon naught RL, which is cancelling now. L and L cancel. Can you write the last formula? This is the last formula. E is equal to lambda by 2 pi epsilon 0. Write the last formula, man. E is equal to lambda by 2 pi epsilon 0 r. That's all. Easy derivation. 3 marks you will get it. Jacob Ton Cadicini. Jacob John is here. Jacob Tom is here. Banging. Abhishek Chandra is here. Abhishek Chandra.
Yes, sir. I'm here.
Jacob. Yes, Jacob? Abhishek?
Sir, I'm here.
Melvin, what's your name?
Sir, Abhishek.
Okay. Melvin is here? No. Tanish Abe is here? All are bunking the class, all are there or not? Okay, can you write in vector form? I don't last up. In vector form. Can you write one more sentence? In vector form. Not compulsory, but you write this one also. Can you put a vector sign for E? E is equal to lambda by 2 pi epsilon 0 r into n cap. Finish that one. That also write it better. Where n cap is the radial unit vector. Just multiply by n cap, that's all. Not compulsory, but right. Sometimes in the exam they're asking. Vector form means put an n cap only. That's enough. That's enough. Derivation is over on the top. E is equal to lambda by 2. I hope derivation is okay. First you write on flux, then Gauss's law, equate it, then make a Q as lambda L. That's all. Finish. Mansoor finish. Mansoor. Around second application number 2, please. Second application. Field due to an uniformly charged infinite plane sheet. Field due to a uniformly charged infinite plane sheet. Finish. Heading over. Right. Yesterday I told you lambda is linear charge density, sigma is area. Okay, they are using sigma here. And on first sentence, let sigma be the uniform surface charge density of an infinite plane sheet. Let sigma be the uniform surface charge density of an infinite plane sheet. Finish. Next sentence. Take the Gaussian surface to be a rectangular parallelepiped of cross-sectional area A. Take the Gaussian surface to be a rectangular parallelepiped. So, parallelepiped means a three-dimensional picture of a parallelogram, okay? Of cross-sectional area capital A. Finish. Sure. Can you leave the space for the diagram, please? You can do at home, okay? Please. Can you leave some space, 4 or 5 lines for the diagram, all of you? Write down the electric flux through electric flux through the two surfaces is electric flux through the two surfaces is phi is equal to E into 2A. There are two surfaces there on both sides, okay? Can you see electric flux is going to the right and the left? E into 2A. Equation number 1. Next, according to Gauss's law, according to Gauss's law,
Sir, could you repeat that previous statement again, please?
electric flux through the two surfaces phi is equal to E into 2A. Finished? Equation number 1. Finished? Hello? Next, according to Gauss's law, all of you know that? Why phi is equal to what? Yeah. According to Gauss's law, phi is equal to Q by epsilon naught. Equation number 2. So, from one on to right, E into 2A equals Q by epsilon naught. E into 2A is equal to Q by epsilon naught. Finish. E into 2A is therefore E is equal to, therefore E is equal to Q by what? Q by 2A. Epsilon naught 2A. Huh? But Q is equal to, write down, but Q is equal to sigma A, the total charge. Can I substitute there now? Q is equal to sigma A, substitute. Therefore, E is equal to sigma A by 2 epsilon 0 A. I think A and A will cancel. A is the area of cross section. I mentioned that, isn't it? A and A will cancel. Last formula is what? Tell me. E is equal to. Very good. This is the last formula for that. Please make note. E is equal to sigma by 2 epsilon 0. Put it in a box. E is equal. Can you write the vectorially also, please? I don't. Vectorially or in vector notation. Main formula is this one. E is equal to sigma by 2 epsilon 0. Put in a box. Don't forget the formula, please. In vector notation, you can write E is equal to sigma by 2 epsilon 0 into n cap, where n cap is a unit vector. Where n cap is a unit vector. So I hope both are okay. Simple derivationally, you can manage very easily. All of you leave the space for the diagram. Diagram is important, please. Now the last application we are going now. %, one question will be there for your exam, okay? Please take care. Last application. Field due to a uniformly charged thin spherical shell. Last application. Chapter is getting over, okay? Chapter is finishing now. To an uniformly charged thin spherical shell. Raisi Tanvir is writing? Are you writing? Goodbye. Field it to a uniformly charged thin spherical shell. 11:25 is finishing, isn't it? 11:25 classes are getting over. Then you have how many minutes break? 10 minutes. 10. You have to be here only, yeah? Okay, write down field it to an uniformly charged thin spherical shell. Getting over? Can I start? Okay. Write down, let sigma be the, write down, let sigma be the uniform surface charge density of a spin spherical of radius r. Let sigma be the uniform surface charge density of a thin spherical shell of radius capital R. There are two cases, you know. One, the point can be outside the shell, and point can be what inside the shell. So the two cases are there. Can I write down? Case one, field outside the shell, please. Case one, field outside the shell. Finish. Heading, subheading. Field outside the shell. And on P is a point. P is a point at a distance. P is a point at a distance. Don't make a mistakes. You have to write small r only, please. Don't put capital R, then it will go wrong. Can you see the letter? R, small r. Don't mess up the two radius. Consider a point P at a distance r from the center of the shell. R from the center of the shell. Finish. R from the center of the shell. Next sentence. To calculate the E at P, we take the Gaussian surface to be a sphere of radius r with the center O passing through P. To calculate T at P, we take the Gaussian surface to be a sphere of radius small r and with the center O passing through P. Finish. Can you draw this diagram first? This diagram is needed for me immediately. Please, small diagram only, takes less time. Please draw it, but draw two circles only. One is capital R, one is small r. Can you see the diagram? Figure A. Please draw it first. Gaussian surface is the dotted line, okay? Dotted line is the Gaussian surface. What is the surface area of a sphere? 4 pi r squared. Good. Don't take it 4 by 3 pi r cubed. So surface area is 4 pi r squared. Okay. Diagram over. Head on. Flux through the Gaussian surface. Write down flux through the Gaussian surface. Flux through the Gaussian surface phi is equal to E into 4 pi r squared. Small r squared only, okay? Equation number 1. What can be the next step? Flux written. Next step is according to what? Gauss's rule. Very good. All are I am going in the similar manner, everything. So easy to understand. Flux, normal flux, then Gauss's law. Write down according to Gauss's law. Phi is equal to Q by what? Epsilon naught. Question number 2. What can be the next step? From 1 and 2. Finish? And on from 1 and 2. E into 4 pi r squared is equal to small r squared only. Don't make a big r's, okay? Q by epsilon naught. Therefore, E is equal to Q by 4 pi epsilon naught r squared. Isn't it correct?
So could you repeat the statement?
Sure. From 1 and 2. Did you write equation 1 and 2? Hello?
Yes, sir.
From 1 and 2, equate the right hand side now. E into 4 pi r squared is equal to Q by what? Epsilon naught. I'll finish, 1 minute while I finish. Therefore, E is equal to cross multiplying, getting it. Okay? Are you okay, man? Somebody asked it out.
Yes, sir. Yes, sir.
Hello? Last step, I take only 1 minute only maximum. If I don't, but Q is equal to, I don't, but Q is equal to, you have to find the total charge. Q is equal to 4 pi r squared, capital R squared into sigma, bracket your right, total charge. Can you replace by that one? Is equal to, what is formula? Q by, what is formula? Yeah, instead of Q, you replace by 4 pi r squared sigma divided by epsilon naught small r squared, isn't it? The same derivation only, I slightly changed only steps here and there. So 4 pi and 4 pi will cancel. Last step is what? Sigma r squared by. Last step, please. Yeah, is equal to. Please write down sigma r squared by epsilon 0 small r squared, please. Hello. This is the last formula, please. Can you see it? Hello. Hello. Clear? And the other one also given. Correct. I think I'll ask questions tomorrow on this. Please, all of you should learn the three applications nicely, and the diagram should be drawn. Okay. Bye bye. Thank you. There is no vector is there. If you want, you can write it down. They put r cap. If you want. That's compulsory. Okay. Thank you. Bye bye. Take care. 11C, please move out slowly. The boy should not harass you. Okay. Thank you. Bye bye.
Thank you, sir.
Tomorrow I'll ask questions to all of you. These three applications, please. Bye bye. See you.
Thank you, sir.
Thank you. Thank you very much. Bye.
Thank you, sir.
Thank you. These three applications are important. All of you put learn, please.